Hey guys, this is some online help for the practice problem on surface area and volume of a rectangular solid. And before I get into the mechanics of exactly how to do the problem, I thought it might be a good idea to explain what the heck is the difference between volume and surface area in the first place? Because I think that sometimes it's hard to know how to use the formula if you don't understand what the formula means. And I'm going to start by doing the volume first because in my experience, a lot of people find that easier. And I've got a rectangular solid, or better known as a box here, that has the dimensions. It's 10 units high, it's 15 units wide, and it is 5 units long, or back. So we're going to find the volume of that box. And whenever you're finding the volume of something, you're basically figuring out exactly, if I were to fill up this box with cubes, how many cubes would fit inside of the box? That's why whenever you are finding the volume of something, you use like inches cubed or feet cubed or whatever the unit is, you use cubed units because you're literally figuring out how much space is inside of this shape. If I were going to fill it up with cubes, how many cubes would fit in there? And so I'm going to actually kind of show you what I mean here for a second. So this little button right here, if I hit this cube button, it's literally going to fill up this box with cubes. And because the box is 15 units wide, to fill up the bottom of the box, I need 15 units that go across the box. So it takes 15 cubes to fill up each row. And then, of course, because the box is 5 units deep, so if you count like it's 5 units deep, that means it's actually going to take 5 rows to fill up the bottom of the box. So I'm going to click here on the row. I already have 1 row, 2, 3, 4, and 5. So I've placed a layer of cubes. I kind of unfolded the box for a second here. So see, box is folded. Here's your little inside view. So I filled the bottom of the box with a layer of cubes. And I knew how many cubes to put in there because it's 15 cubes wide and 5 cubes deep. So that means I needed a total of 75 cubes to fill up that bottom layer of the box. Now I need to apply layers to fill up the entire box, and I do that by thinking about how tall it is. So we already know from the problem that the box is 10 units high. So that means we're going to need 10 layers of 75 cubes, or in other words, 75 times 10 to fill up the box. So if I've already filled it up with 1 layer, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I've now filled up the box all the way with cubes. And to figure out how many total cubes are in there, in other words, what the volume of the box was, I took how wide it was, which was 15. I took how long it was, like how far back it was, which was 5. And I took how high it is, which is 10, and I just multiplied all those numbers together. So that's where the formula length times width times height comes from. So the 15 times 5 told me how many cubes were in the bottom layer, and then I needed 10 layers of cubes. So that was a total of 750 cubes. So let's just say this is inches, for example. So it'd be 750 cubic inches. So the volume of the box is 750 inches cubed. Now surface area can be a little bit harder for people. So I'm going to open up the box again. I'm going to clear all these cubes out of here. So the surface area means the area of the surface, the outside. So basically, if I were going to take this box and unfold it, open it up, what would be the area of each of those faces, the outside of the box? So because we know that the front of the box is 15 wide and it's 10 high, to find the area of the front, we would do 10 times 15. So we know the area of the front is 150. And because we're talking about area, this would be units squared. So let's just call it inches. So inches squared. So the front is 150 inches squared. Now, if there's a front of the box, obviously there has to be an identical back. So the back side, the area is also 150. Now let's look at the area of the side. So this side right here, we know, I just kind of folded it up. So we know that the bottom of it, that it's 5 wide, and the side of it is 10 high. So 10 times 5, that tells us the area of the side is 50 square units. If we were doing inches, that would mean it was like 50 inches squared. So if the right-hand side of the box is 50, there's obviously that identical left-hand side of the box that is also 50. So far we found the area of the front and the back and the sides. So now we've got the area of the bottom. And because it's 15 wide and it's 5 long, that's going to be 15 times 5. So the area of the bottom is 75 units squared. So if the bottom is 75, and because it's a box or rectangular solid, it's obviously got this identical top of the box, which is also 75. So if we add all of these areas together, okay, so we found the front, which we found the front to be 150, and the back was 150. So the front and the back, each of the sides was 10 times 5, so that was 50. The side was 50. And then the top was 75, which meant the bottom was 75. So if we add all of those individual areas together, so there's my front and my back, here is my top and my bottom, here are my two sides, that gives me the total surface area, so the outside of the surface of the box. So if I add all that together, I get a total of 550. Again, I'm just going to say we're using inches. It doesn't really give us units here, so that would be inches squared. So let me go back to that particular example problem, relate that to the My Math Lab example. So now here's the exact same problem from the My Math Lab example, and so you can see I use those same dimensions. So that is where the actual formula came from. So A asked you to find the volume. So again, that formula is length times width times height. So that's why we took 5 times 10 times 15 and added them or multiplied them together. And you got a total volume of 750. In this case, we're using centimeters. So that's centimeters cubed. And then remember the formula for surface area, which was given to you by My Math Lab. The formula is right here. So what they're saying, because the formula can be a little bit confusing, but what this formula means is exactly what I just told you a second ago. Okay, so 2 times length times width. So because it's saying length times width, and then you're multiplying that by 2. You're really doing exactly what I just did a second ago in the problem. So if this is your length and this is your width, for example, okay, so you're basically finding the area of that bottom of the box. You can't really see it in the diagram, but that's what you're doing, because the 15 and the 10 tells you how wide and long the bottom of the box is. So that's why you're doing 15 times 10, so that gave you the bottom of the box, but because of course this is a box, if the bottom is 15 by 10, then the top is also 15 by 10. Excuse me. So that is why the formula is also telling you to multiply that by 2. So 2 times 15 times 10 would give you 300. Which is exactly what we just did a second ago in our example problem. We found the area of the bottom by multiplying the width and the length, and then we multiplied it by 2, because if the area of the bottom is 150, the area of the top has to be 150 as well. Then, width times height, me get this stuff here out of the way. So again, the width and the height. So you're really finding the area of the front of the box, right? Because you're doing 15 times 5. So if that's the area of the front of the box, that means it also has to be the area of the back of the box. So that is why the 2 is in the formula. So this is what we did a second ago. So 2 times 15 times 5 gives you 150. And finally, the last part, the length times the height. So the length is 10. If this height is 5, obviously the height right here is 5. So again, you're finding the area of the side of the box. So that's where the 5 times 10 came from. And if the right-hand side is 5 times 10, obviously the left-hand side of the box is 5 times 10 as well. So that's why there's a 2 times 5 times 10. So that would be 100. Add it all together, and you get a total of 550 centimeters squared. So I've just kind of shown you 2 different ways of finding the surface area and volume of the box. Hopefully that helps you out a little bit. And let me know if you have any other questions.